Doing today?
Excellent.
Good? Okay. My name is Victor Mushkaiten. I used to be a founder of AVIcode. I recently joined Microsoft, and now I'm part of System Center Operations Manager team. And today we'll be talking about AVIcode and how to use AVIcode in real life. I will try to stay kind of high level to not steal the thunder from Chris and Sean, who will be delivering implementation demos and configuration present talks, I think, Wednesday, and also how to troubleshoot, like some real scenarios, how to do production troubleshooting, I think, on Thursday. So I'll try to cover mostly conceptual AVIcode implementation. And before I kind of dive into my presentation, how many of you have heard about AVIcode before? Wow, surprised. OK. How many of you would consider themselves to be IT pro and have like System Center Operations Manager? OK, quite a few. And how many of you consider themselves to be more developer-oriented and have TFS? OK, so I'll try to cater both, probably on upside more, but definitely cover the development scenarios. OK. So what we'll talk is, I want to make sure that we all understand what problems we are addressing with AVIcode. I'll talk about the market that we used to play. And then I'll cover high-level AVIcode solutions and do some demos. But before we kind of go into my presentation, when I was trying to think and kind of summarize what we've been doing all these years when we were developing application monitoring solutions, the closest thing that I kind of came up with was one of the lectures that I had during my university years around the electron, and that it's very hard with certain certainty at the same time identify the momentum and the position of an electron. Through many implementations of AVIcode solution, I realized that it's somewhat similar to what we hear from customers. In many cases, they have no clue how many applications they have, how those applications end up on those servers, and where this whole thing is going. OK? So just hold that thought. I will try to, at the end of the presentation, kind of get to this point, and hopefully it will make more sense. So when we're talking about modern application, the most critical thing is live site. Site should be up and running, regardless of the new releases and new features. Site has to be up. I've seen teams where a development team dedicate 25% of their resources for sustained engineering to make sure that site is up and running. 25%, 1/4. That's a pretty big chunk of their dev resources. That's how serious and how important it is. Now, in order to get that service continuity, we see that it's usually a shared responsibility between development and operations. And in order to get to that shared responsibility, dev and ops should see common telemetry. That whole process should be transparent. Now, how typically support works in the organizations? When operations are trying to understand how to monitor applications, developers are basically, they're not talking about availability, usually. They have their QA, they're fixing bugs, but they're not thinking in terms of whether something is up or down. And they're trying to understand, what do you mean? Is it failing? It's working here on my box, on my staging. And, but operations know firsthand that it's not working in production due to, let's say, high load, or due to the fact that developers cannot possibly reproduce the same database. Let's say I have a EMC box with terabyte worth of data. I cannot have possibly reproduce the same kind of storage in my QA environment. So I might not see the same thing in pre-production environment. So then developers are trying to get more information out of operations, but operations are not capable to provide that information. It's not their fault. It's just the fact that in big organizations, I've seen over 1,600 different applications supported by operations folks. And with no standardization, it's a nightmare. Because every application is writing in their own event log, their own type of information. And it's very hard to operations folks to really kind of, in a standard way, to understand what's going on. So developers are getting somewhat defensive, saying, well, it's working here, it's not working there, then most likely that's your code. And then basically conversations getting very philosophical. But the point is that due to very unreliable incident detection, and I've heard that some people telling me that Twitter is their best monitoring solution, limited communication between dev and ops, you have a lot of this finger pointing and blame storming going on. And at the end, essentially, MTTR, mean time to resolution, is affected. Okay? So I believe this is probably similar to what you've seen at least once in your life. And this is not a new problem. Gartner, for example, defined the whole market, application performance management market, that specifically address this area. For example, System Center, historically, System Center Operations Manager used to play in a different market called event correlation and analysis. That primarily target infra monitoring space. AVIcode was targeting purely application monitoring space. And according to Gartner, the solution that play in this market, you can break into 5 pieces. First of all, it provides a real-time application kind of discovery. Because the first thing, you need to know what you have in order to start monitoring all the pieces and how they work together. Second, you need to know how your end users really experience your website, your service, rather, right? The third is once you know your critical transaction, let's say my login could be a critical transaction. So you know that people can log into your site, your main homepage, your main dashboard, or your, I don't know, checkout, and so forth. You can define those critical transactions and be able to see whether those transactions are up and running, if they're failing, how they're failing, and so forth. And the fourth piece is essentially deep dive. So every time when there is a problem detected, whether from the client side, from the end user perspective, transaction perspective, you should be able to collect enough information so you can reproduce this problem and fix it. And on top of all the data that's collected by these 4 kind of quadrants, you have to have a BI that would allow you to see the trends, that would allow you to see, I don't know, ability to compare before and after type of things. So that's what AVIcode is. Essentially, this is a low overhead solution that was designed to monitor production system 24/7. It doesn't require any source code modification. So you don't have to rely on developers' instrumentation. And the beauty of such approach is that you're not tailoring your monitoring for each individual application. And if you're supporting, I don't know, a couple hundred applications, you can establish essentially a standardized way to monitor them all. It detects application reliability and performance problems, and I will cover what does it mean a little bit later. It integrates into problem management workflow and provides analytics on top of data it collects. So if you look at the architecture, AVIcode architecture, it's an agent-based solution. And before I got the comment that this is pretty complicated architecture, believe me, it's not. So it's an agent-based solution. And there are 2 types of implementation you can have with AVIcode. First, if it's a standalone solution. Second, if it's integrated with Operations Manager 2007. If it's a standalone solution, what you have is you install agents on monitored servers, and you install managed infrastructure on a dedicated box. Agents connecting back to management server via web services call, so HTTP or HTTPS connectivity. And every time when agent detects a problem, it collects root cause information and sends that data directly into the management server. Okay? And the management server stores all that information inside SQL database. Okay? And management server provides a web UI for end users, for I don't know, developers, operations folks to actually see the data. That's one type of deployment. Second type of deployment is through .NET MP. You can download that .NET MP from the System Center catalog, where it would install the full-blown UI, operational UI inside Operations Manager. It will implement the enterprise configuration. So from the System Center Operations Manager UI, you would be able to configure and essentially deploy agents throughout your enterprise. And in this case, we're sending data into 2 channels. One, we're sending operational data into Ops Manager console. So operations folks would be able to react on issues, because they're usually 7x24, not developers. And second, we're sending data to our management infrastructure, because that's where we do the event analysis, slicing and dicing, more geared towards development. Speaking about how it fits into overall kind of picture, this is, let's say, this is a little bit different view on AVIcode solutions, where you have users sending requests to your service. Then we have our service telemetry layer, essentially our agents that you install on those boxes that are collecting some data. And then we have our management platform. And you can put our management platform split into like 3 major buckets. One is our integration with operational scenario, and that would be System Center Ops Manager and .NET MP. Second would be our SE viewer, which we call Structured Event Viewer, and that's geared more towards problem management, troubleshooting kind of scenario, supporting scenario. And third is our analytical BI interface, which we call Advisor. And don't confuse with System Center Advisor. So if you look at those 3 different buckets, typically Ops Manager is used inside NOC, where you have operators who react on volume-based problems. Let's say one performance degradation or one exception failure is not really an important thing from operational standpoint. They care about the volume. They care about the percentage of users affected by performance degradation. Let's say if more than 10% of my users are affected, then I need to start doing something. On the other hand, from development standpoint, even one exception or one performance degradation might be an indication of inefficient code or something that they need to fix. And that would be affecting down the road. So in reality, what operations folks mostly concerned, they're mostly concerned about the configuration and security problems. And we've seen how our solution have been used during the deployment very heavily by the operations folks, where you install your new release of your new application or brand new applications. You're trying to exercise its services, and suddenly something is not working. I've seen many times where the issue is because of, I don't know, fat-fingered web config connection strings or connection to web services and so forth. And in this case, those kind of security and connectivity problems most likely would be fixed by operations folks, because they know how to connect. We've seen situations where you have IIS box, you have a firewall in between, you have SQL box. Somebody reconfigured firewall, and let's say 1433 no longer allowed to get to the SQL, and suddenly your whole application is down. Okay? And those type of issues can be fixed by operations folks, and our solution helped that. On another hand, issues with application failures, where your, I don't know, application fails because of a data inconsistency in the database. We've seen many times when, due to some nightly batch file that was run, my database is in an inconsistent state, and application assumes that there is a record. I'm trying to access that record, and I'm getting a DB null exception. That's one very common scenario. Or some type of performance degradation, where when developers are testing with their database and they have, I don't know, 3 rows and everything flies. When they go against a real database, it's not working. I've seen scenarios where there was a very high-profile customers with a report that was taking over 2 minutes. And the operations guy was saying, well, my database is screamingly fast. I cannot track any SQL statement that are slower than 2 milliseconds. So it's not my fault. Developers saying, well, it's working fine here in pre-prod. Well, with our solution, what happened is we found out that essentially, from development standpoint, they had a report table, and for every cell, they had a little query to SQL. So they had over 7,500 SQL calls from one report. And when enough people open up that report, even very beefy SQL, and I've seen that SQL, that's a really big SQL, it just couldn't handle it. Okay? So those type of scenarios can be fixed only by development service engineering team. And that goes to essentially the second support and dev folks. Because they need to be able to look at the problem and start slicing and dicing the problem from their perspective. And in their case, let's say there is a failure. In many cases, this failure that happened on that page is the same failure that happened on another page, because the sprog that they're calling is failing. And it's failing 2 different pages. So they need to be able to have a UI, some kind of tool, that would allow them to look at the problem and group the data the way they want it. Okay? And that's another area that we're addressing with our solution. And the last one is essentially biz and app owner. In many cases, we have many reports, but I believe the most popular one that I'm going to show you is the application scoring, where we enable out of the box application score and allow you to compare hundreds of applications and see the worst performing applications, let's say, on your left. Okay? And I've seen scenarios where essentially monthly dev managers were sitting in the room and waiting for a report to generate, and they were betting who's going to be on the left side. And I'll show you some of the reports, and but it shows that it's very important for a business to understand where they are in order to properly allocate resources. It's very important to understand, like, before and after analysis, when I did the release, right? Whether I'm improving my performance or not, whether I'm improving my reliability or not, okay? So that type of reporting is available through Advisor, AVIcode Advisor. Now, if we go a little bit now deeper into telemetry platform, into our agent. And again, what you see here is oversimplified notion of a service. So service is just a bunch of application components talking to each other. They usually run within, they sit on top of a platform, and then they rely on some external dependencies. Okay? And the application components is a set of functionality logically grouped together in a single unit of deployment management support. Usually it's something that runs inside the process and make cross-process, cross-network calls to another component. Okay? So what we do, we have a bytecode instrumentation technology that allow us to, on the fly, instrument application. And we are monitoring essentially requests. So let's say you have a entry point, your, let's say, front-end web services, or ASP.NET application, rather. What we're doing, we're monitoring all the requests, HTTP requests, to that application. And based on those requests, we're measuring, let's say, availability. In terms of how many requests went through fine, how many requests failed. And that's more, I would say, reliability metrics. We're monitoring the performance. You can specify performance SLA, let's say 5 seconds. And every time when request is slower than 5 seconds, we will capture that request. Okay? So you can come up with the metrics for your application. And we cover, out of the box, we cover different type of application components. It could be ASP.NET, it could be web services, Windows service, COM components, and so WinForms, and so forth. If you go a little bit deeper into the request itself, we're measuring the performance SLA on top of that request, and then we detect critical failures of those requests. Let's say there was a request to a page, and then inside the page there was an exception. But that exception didn't surface to the user. And most typical exception, developers would probably know, the thread abort exception. Every time when you do page redirect, .NET Framework will throw a thread abort exception. So those exceptions should not be treated as true critical exceptions. And our solution should not be collecting any data. So we have ability to intelligently differentiate between critical problems versus non-critical problems. Moreover, it might sound controversial, but our job, our goal with this solution is not to collect data. Because when we're talking about production monitoring, the last thing you want to happen is that if this monitoring would significantly affect either performance or reliability of the software itself. So we're trying to be extra careful and throttle our monitoring as soon as we detect that there is, let's say, unusual load on the server, or there is an unusual load of exceptions or performance events in the server. Because there is no point to collect data. Let's say 1,000 users click on a button doesn't work. Why do you need 1,000 of almost identical problems? We will collect first 3 problems per minute, and then we'll keep a counter that the same problem, the same button didn't work another 997 times. The next minute, again, we'll collect first 3 and 997 counters. And then you have those kind of settings for per minute, per hour, per day. So because our point is to collect a problem that can be fixed rather than every occurrence of that problem. We keep a counter, but we're not collecting the runtime data for this problem. We also have ability to create what we call distributed chain. Let's say we're monitoring multiple computers, multiple components rather, talking to each other, installed on multiple computers, right? What we do, we have ability to collect data that's coming to our management server absolutely independently, and then stitch that data together after the fact. And the way we're stitching it, we for some mechanism, we have a GUID that we piggyback and send back and forth. In some cases, we're essentially, it's pretty simple. You know the caller and callee parameters and the name of the function, and we do the matching on the back end because we know the runtime context of the caller and callee. Okay? So, and for all those requests, we are capturing metrics: throughput, your calls per second, average execution time, percentage of performance failures below certain SLA, percentage of exceptions. Okay? And then we have a special treatment for certain requests that are going against, let's say, we call it dependency. Let's say SQL calls, WCF calls, .NET remoting calls. So for each component, we can discover over time dependency of that component. That really helps to build over time the diagram, if you will, deployment diagram. We call it incremental discovery of the applications and how each component talking to each other. And for those type of requests, we are detecting connectivity and security problems. And the last thing, we're monitoring the workload, essentially the platform CPU, memory, I/O. In many cases, it's tricky because let's say you have web applications. Every time when IIS restarts, all those process IDs going to be new. And it's sometimes very tricky to attach automatically to appropriate process ID to understand the performance of particular app pool. We do that on the fly for you. Okay? We've seen customers, well, the biggest probably customer was with 70 app pools, 70 app pools per monitored box. Okay? And imagine how hard for them to understand which W3, WP pound 1, pound 2, pound 3 is which. Okay? We help with that problem. Now, if you look at the monitoring kind of goal perspective, from monitoring goal perspective, it is really ability to detect, prevent, and fix any type of availability, reliability, and performance issues. And when I'm talking about issues, I want to separate the two types of problems: known problems and unknown problems. Known problems are those for which you know problem signature up front. For example, you have you have, let's say, your applications that's relying on your C drive, right? When you run out of C drive, the whole server will die. That's, I would say, a known problem that you can upfront come up with a rule and monitor for that. Another scenario would be, let's say, connectivity problem to SQL. You can wrap every connection string to SQL, every interaction with SQL in some kind of decoration. And every time when you cannot find SQL, this is a known problem, SQL connectivity. Okay? On the other hand, unknown problem, it's something that you did not anticipate. For example, failures due to data inconsistency. In 32-bit world, when we had 4 gig or even less, 2 gig, or even less, 1.3 gig per .NET process, I've seen even with garbage collected applications, things were not, garbage collector was not fast enough to clean up the memory, and we were running out with memory problems. And the interesting thing, you may be leaking in this function, but you're failing right here. Okay? So those kind of problems really hard to kind of predict and create meaningful instrumentation during development time, and know what needs to be collected in order to fix that problem up front. So for some problems, you do reactive monitoring, where you can, proactive monitoring, where you can proactively monitor for, let's say, availability. With ping synthetic transactions, I can see whether my home page is up, right? With, let's say, I can log in with some dummy account, and that guarantees me that my database is up. I can try to process credit card transaction against my clearinghouse, and it shows me that my link to the clearinghouse is up. That's type of active monitoring, proactive monitoring. The same thing would be now reactive monitoring would be failures due to I don't know, application bug. Those you can detect only at the moment of the failure. So what AVIcode does reactive monitoring. In other words, we are monitoring failures when they occur. And at the moment of the failure, we collect the root cause information about that failure, and we send that to operations manager as well as AVIcode infrastructure. Now, if you look at this chart, what I was trying to just express here is that when you release a new software, you know very little about it. You may write some management pack for it. Developers may write some instrumentation. But the number of unknown problems versus number of known problems, number of unknown problems is much higher. Over time, what happens is you learning, and you either coming up with a workaround, you're fixing some problems, and over time it converge, and new release happens. I remember a long time ago, there was one such scenario. I wrote a component for, back then it was transaction server, Microsoft Transaction Server, and when it was reporting into event log, a very descriptive method, method tilde of object tilde failed. I didn't know what was that problem. But ops guys discovered that if you see that message, you just restart that component, everything's fine. And this was a normal, this turned from unknown problem into known resolution. But I never got to fix that problem because new release came and essentially invalidated the whole previous knowledge and tribal knowledge that operations had about our service. Now, with agile releases, with the very high frequency of changes in the environment, if you're using, I don't know, cloud with cloud elasticity, or you're relying on third-party services, it's really, it's exacerbated the problem of not really know what's going on and invalidating the knowledge about your application servers with almost with every release. So that's, I essentially came back to this fighting the uncertainty. Our job was to be able to detect problems as soon as possible and help people to know what they don't know. Okay? So application monitoring, it's essentially, I'm going to do a demo right now and show how AVIcode can be used in production to monitor applications. Okay. Okay. Laptop. C. Okay, good. So here's my demo. And I'm going to show you DinnerNow website. How many of you have seen DinnerNow before? OK, so I'm going to show you again. This is a simple website where I can search for restaurants and even order some meals. So what I'm going to do, I'm going to search for restaurant. And as you see, it will take me some time to get to the list of restaurants. Now, I'm going to go from the kind of lowest level, from the problem troubleshooting, all the way up to the operations and then to analytics. So from the problem management standpoint, our infrastructure was able to detect that there was a request. And we collected data from the client side. Now, what we did is, essentially, before we spit out page to the end user, we instrumented payload. We instrumented HTTP. And we added a JavaScript include that essentially attached to the DOM model, to all the timings inside DOM model. So we can collect this nice graph. We can see how much time we spend on the network, how much time we spend on the server side, how much time we spend before DOM is ready. And DOM is ready. It's an event where you can consider that the page is ready for customer clicking on it. It's not necessarily that all images are there, but customer at least can start clicking on the page. And then peripheral load, it means that when all the images are there, and we have also timing the Windows on load event. And we're considering the whole thing to be the load time, page load time. You also can look at this from two perspectives. You can look at it from the session perspective, where, let me see. Where you can see how your front end communicated with your back end. And that's kind of horizontal thing. You can see based on a session ID or based on a user ID. Or you can look at it from the transaction perspective. This is my client calling my ASP.NET front-end server, calling my back-end web services. And I can dive into the back-end web services and actually see the SQL statement that was causing performance degradation. Okay? So that's essentially ability to see what was going on from the client all the way down to the, in this case, SQL statement that was causing performance degradation. And again, you don't need to do anything, any code instrumentation to get this type of data. Moreover, at this time, what we did, we collected performance counters. Let me show you a couple of performance counters that we've collected. What we do typically when you collect performance counters, it's like every, 5 minutes, every 15 minutes. And you create trending reports based on that. We do that as well, but this is a little bit different type of perf counter data collection. What we have what we call troubleshooting performance counters. We have a running window of 15 seconds every 9 seconds on the server. Every time when exception or performance degradation occurs, we take a snapshot of that window and we attach it to the event. So effectively, what you see here is 15 minutes of perf counter data prior to the failure, prior to the performance degradation. And you can add any performance counter here. That's up to you. That would help you to troubleshoot the problem. And in many cases, we see that this is very helpful because the perf counter data that you have otherwise, let's say every 15 minutes, might not be representative to the problem that happened in between those two samples. Okay? Now, let me show you how, from the ops standpoint, people would use it. here's my, again, my demo. Let me go back to my demo. Dinner now. And I'll try to click cart. And let me log in. And I got this. Clearly not good thing. Now, right now, operations folks are not even aware about this at all. These problems, they're aware about this only when end user calling help desk, creating a ticket, and they're trying to figure out what to do with this. But since they don't know exactly what happened, sometimes users cannot explain what happened, it's tricky. In many cases, when developers are collecting these call stacks, they don't see the actual runtime information, and that makes all the difference. Because when they try to do the same, access the same page with their login, everything works. And it doesn't work really only with that user login because of, I don't know, data corruption for that specific users. So here I have Ops Manager, in this case TFS connector, and this is my shopping cart failure. What I can do at this point, I can go and see that this requires access to the application source code, right? And I showed it during Keynote, that I won't be able to fix this. Most likely, this is something that I need to escalate to service engineering team, to developers. So what I'm going to do is I'm going to send it. Oops. Well, come on. I'm going to send it to, set resolution state, to engineering. At this moment, connector will take that alert, create work item inside TFS, and associate everything to that with that work item. So what I'll be able, OK, here it is. What I'll be able to do is I'll be able to see that that alert in the list, in the problems queue for support team. Moreover, I would have my work item ID inside. OK, so I have this. Now I can track what's going on with this problem inside TFS. So every time when there is something new happening inside TFS, I'll see it reflected here in the history. Moreover, if they write something to you, it will appear here. Let's say steps to fix the problem. Okay. Now I'm switching hat. If I'm a service engineer person, and here's my problem, I can do 3 things with this problem, essentially. I can ignore it. I can close it immediately. I can propose a resolution. And I can essentially go to history and whatever, resolution. OK? I can do that. Or I can accept it, which will show to ops guys that this issue is in the works and we accepted it. I can assign it to a person responsible for a particular area. Okay, and let me assign for myself. Right? And now that person would be able to start troubleshooting this particular scenario, because I, as a manager of this queue, I know that that person, he or she, is specialized in this particular problems or particular piece of code and so forth. Now, we're not creating bugs, because we learned that the developers were not very happy when ops folks were creating bugs directly in their queues. So what we're doing instead, we're creating operational issues. And then if support engineer, rather, would consider that that particular issue is something that they need to fix, they would create a bug, normal bug, associated with appropriate sprint, and link to this operational issue. Okay, that's how it works. Now, how the troubleshooting would work in this case? I'd be able to see the link. Oops. Back to our management infrastructure that I showed you. Okay, that's how we use our SE viewer. And I would have access to the same thing that I showed you before, let's say parameters, perf counters. I would have event properties. I would have parameters for the functions. And I'd be able to jump directly into the line of code. Okay? So we were able to collect data that would help our developers to really troubleshoot and understand the nature of the problem. And that we do without requiring A, developers to write anything, and B, operations to turn on, turn off stuff. And I think those two things are very key to the monitoring solutions, because it has to be real time all the time, and it has to collect meaningful, relevant information at the moment of the failure, so you can troubleshoot and understand what's going on. Okay? And that's essentially end-to-end story from the development standpoint. Now, this is all great. And I remember when we didn't have the BI analysis, and we were showing our screens like this with, I don't know, hundreds and thousands of events, people were saying, well, this is great, and what? And we were trying to explain, well, this is good. You need to fix this. And they keep telling us that we cannot fix it all. Give us, let's say, top 5 problems that are affecting 80% of our problems, our applications. Okay? Give me like a quick win, because I got to show to my boss that I'm on top of things. And that was the core principle of Advisor, AVIcode Advisor. That essentially we created the BI analytics on top of data that we collect that would help you identify those quick wins. That would help you see, let's say, before-after type of analysis. And that would allow you to compare different applications to each other so you can properly allocate resources. Let me show you. First report is this one. This report shows a bunch of applications, and there were over 200 different applications that we were monitoring. And as you see, we show first 20. And first 20 applications contribute to 95% of total problems that over 200 applications generate. But the interesting thing that first 5 applications contribute to, as you can see, 65% of all the problems. So here's my quick wins. I need to address this first 5 applications, and I cut my problems in half. Okay, clear. Now, if I look at this web phone applications, and I'm talking about big load. I mean, just millions of requests, and so the statistics over a period of time. I can quickly see that in this particular case, this web phone, fictitious web phone application, even though it's number 2, but you see that the top 4 problems are from external web services. And I've seen that happen. So when developers are trying to understand what's going on with their app, they're realizing that this is not necessarily their app. They're relying on, I don't know, the billing web service. They're relying on common authentication. Yeah, common authentication was one of the real scenario. That the common authentication web service was slow, and therefore everything was slow. Okay? And that's really helpful when you're trying to kind of understand what needs to be done. Another typical, and these reports usually run every month when people are trying to understand how applications are doing, like overall, see the picture of a portfolio, let's say, of services that they run. Another scenario would be, let's say I had a release, and I'm trying to figure out whether I'm doing better or worse. So we have application status report that allow you to compare, let's say, before and after with a baseline. And we show every KPI with what we call time perspective, and which means that you have a time, let's say now or yesterday, versus you have a time span, let's say a week or a day, and you have a baseline, let's say last 30 days, last 6 months. And what we show you, let's say this week versus previous week versus baseline. And on this graph, you see, for example, how 1 week compared to another week compared to baseline, and from, let's say, event count history, number of problems that we collect. it's pretty much the same. But look what happened on Monday night. The load on the platform doubled. And I'm talking doubled from 7 million calls per hour to about a little over 17 million calls per hour. And that's that's a real data from very well-known real-time website. Doubled the load. Interesting, the CPU doubled, which makes sense. You have twice as many requests, you double the load. I/O doubled. But this is, I think, speaks to the quality of the service. The average time, request time, didn't even blink. I'm pretty sure that all developers were really happy to see that. Okay, and quite frankly, I've never seen this kind of graphs in any other customers. Usually, it changes, especially when you're talking about not you had one user, now you have two users. We're talking about they had like 7 million calls, and now 17 million calls. Okay. So this is an example where I can compare before and after. And what's more important is that I can, without even setting any SLA, any KPI, I can eyeball this my performance. Let's say I don't know what I/O should be, really, on my laptop, let's say. But if I show you my I/O today versus yesterday versus baseline, I kind of can develop an opinion, whether it's better or worse. Maybe it's OK, but at least I can compare and decide. And that's what we do. Another thing is we have a notion of a new problem versus old problems. And let's say problems that happen within that span that just started happening, those are new problems. Let's say I had a release last weekend, and this weekend I'm trying to understand how many new problems I have, and I can see that. For example, in this case, I have 9 new performance problems and 322 exception problems. This also shows an interesting phenomena. Not every event is a problem. Let's say you have a button that doesn't work. 1,000 people click on that button, as I mentioned before. It's just one problem in reality. Well, there are 1,000 of events, or we count 1,000 times, but it's one problem. So in this case, for this 9 new problem, there were 117 events. Again, it helps you understand whether your release is successful or not successful. And we show you top 10 problems, top 10 new problems based on frequency. We show you, and that's another thing. We usually show you from, with these, again, Pareto-like analytics. We show you that these top 10 problems contribute to 89.4 of all new problems that you introduced with this release. Okay? And this top 10 problems is 89.8 for all your application problems. So this is your quick win from development standpoint. I need to address this 10 problems, and I won't have the issue with my app, essentially. Okay? And the last thing is I was going to show you is the performance analytics. In many cases, when we come to customers and we ask customers, so what is your SLA? They say, well, our SLA is 5 seconds. We start monitoring with SLA 5 seconds, and we collect, like in this case, over 6,000 events. That's not good. In this particular case, what you see is majority of their events is between 5 and 10 seconds. Okay? Then you have also pretty big chunk of requests between 10 and 15 seconds, then it kind of goes down. So if 93% of all your problems between 0 and 15 seconds, don't set your SLA to be 5 seconds, because we will be collecting way too many data. So this would allow you to set SLA, for real SLA, for your applications. And then what we recommend customers essentially go down and work their way down, lowering the SLA while fixing issues. Or, that's another very important feature, stating that, you know what, we'll never be able to fix this thing. We had a customer where they had a front-end web service that was mainframe on one side and SQL Server on another side. So essentially, what was happening, all the calls that were going to mainframe were 30 seconds plus, and that was OK. Every calls that were going against SQL were very fast. So what they wanted to do, they wanted to mark calls that are going against mainframe is OK. It's OK to be 30 plus seconds. Versus calls that are going against SQL, they have to be performing fast. Okay? And our solution supports that differentiations as well, on per request type of metrics, not only per application, but also per request. And that's important. And again, from the analytics standpoint, ability to kind of slice and dice the data and see chunks, let's say how much time we spend inside internal execution, how much time we spend inside database, how much time we spend with external web services. So that's very important when you're trying to analyze what you need to do next with the application. Okay? So going back to the PowerPoint, so the value that AVIcode provides essentially cut across the lifecycle. From the development standpoint, you may not need to instrument as much. You may need to focus only on expected problems. Essentially, I know that there is a call to my external web service or external resource. I need to decorate that call to know and to provide prescriptive, actionable information to ops guys so they can fix the problem. Okay? From the QA perspective, it's really helpful for QA folks to collect this kind of information so they can also communicate better with development teams. And all the way to the support, where we standardize the type of data that we're collecting, and we differentiating problems that can be fixed inside operations team, by operations team, let's say security and connectivity misconfiguration type of problems, versus application failures and performance degradations that should be fixed by development. And we tie it all together with TFS connector now. So from the ops side, you can escalate problems directly into dev, service engineering support queue. And from the business standpoint, these type of a solution, and AVIcode specific solution, helps you significantly lower the total cost of ownership. By lowering MTTR, by simplifying, I don't know, development instrumentation, by simplifying your monitoring requirements, what you're expecting from your developers, you're lowering the cost for your development, you're lowering the cost of monitoring, and at the end, you're improving the customer satisfaction and trust in your services. So ultimately, the AVIcode and System Setter provides a differentiator for your business. It helps you improve your SLA and kind of add that certainty about your applications. It shows where applications have been, where it is right now, and where it's going. Okay? So I kind of came back to the statement that I made at the beginning of this presentation. So if you have any questions, let me know. Go ahead. If you can, just go to the mic.
I have a couple of questions. And during the deployments, we might add a couple of VMs into the production. So if you're before the release, you're like 40 machines that you're serving the requests, and after release or during the release, you might increase your capacity to like a 60 servers. Like when you're comparing, like can you isolate or can you?
Good question. So in reality, we would not be able to show you that you also increase the number of VMs, but we're not monitoring that. We're monitoring the number of calls. Did you increase number of calls, end user calls, to your application after your release or not?
So in that case, then your collection agent is running on 60 VMs. So you're
That's correct. It's agent-based technology. We would run on all 60 VMs.
Okay. So later on, once my deployment is done, and then I move back to my 40 VMs in production with the new code. So I want to verify whether it's taking the exact call that's an end-to-end. Is it will be giving in a comparison between before and after? Or
Again, because we're not tied to the platform itself. For us, we see how many requests you've been processing before, what was the average time for those requests, how many events or problems we've been collecting. So for us, it's essentially the platform is transparent to us. We don't really care. We just care about the load, how much load you're able, throughput, let's say, how much throughput you're able to process, and what was the average time for requests.
Okay, so the next question could be related to the platform. If a machine is failing because you have like 60 machines and there could be one bad box in rotation and that could be causing a spam. So can we filter out based on the machine, or can we see events based on the machine?
Yeah, what you can do is, let's say I have dinner now, and this application runs on, well, let's say it could run on 20 machines, and you would suddenly see that there was no monitored request on one machine. That's what we would see from the application standpoint, that for some reason there is nothing coming from that machine. We would also notice that the heartbeat from that machine is missing, but from the application standpoint, the only thing that would surface is that there's no data coming.
Or is there a customized report that can say, hey, from this machine is the most failed events that's coming from a machine?
Exactly, yes. You would be able to do that analytic as well.
Okay.
And it's interesting, when we were comparing different load balancers, we've seen that some load balancers were distributing evenly, but some, like a normal distribution like this, for whatever reason.
In the examples, I think mostly we are seeing the failed events, but if I want to see a call is successful, but I want to trace what is the beginning to the end call is working, I want to understand, can I do that?
We are not tracing tool.
No, I'm not saying tracing, but I want to say, for example, in your failed events, you mentioned that, okay, how is the SQL call is how much time it is taking. But if I want to see if the call is successful, but I'm expecting that the SQL call should be less than 30 seconds, 30 milliseconds or something, and I want to see a successful call, but what is the exact time the SQL call is taking?
Again, for us, for example, performance calls are successful calls. They were not failing.
So do we track the successful call if I want?
Only if those calls are exceeding SLA threshold.
So the question here was like, I want to do even the performance analysis from this tool or not?
Yeah. This is at the same time you're collecting performance violation and exception at the same time. Is that the question? Because what we're doing essentially, you're setting.
So basically, then in that case, then based on my thresholds, it throws that as an exception. If
it's okay, it's not throwing exception per se.
Yeah, my question here was like, if my SQL connection threshold is 30 seconds, that is the initial application call, okay? But I was debugging something, and then I want to know what is an end-to-end client session is making, and I want to see how much exact time it is taking.
Yes. By the way, we're not talking in terms of connection per se. We're talking in terms of how much time does it take to get responses back from SQL. Let's say if you say 30 seconds, we will capture SQL statement as part of, let's say, this method only when they exceed, let's say this, only when they exceed 30 seconds. In my case, my SQL threshold was, I believe, 10 milliseconds. So I'm collecting essentially every SQL call here. But you would be able to see essentially end-to-end from this screen. This is my client talking to my front end here, talking to my back end here, and we would collect this chain only for requests that were violating SLA. Okay? And we believe that that's the difference between tracing and monitoring. We believe that only this type of monitoring is appropriate for production, for monitoring, where I would agree with you that the tracing is also a valid scenario when you're troubleshooting something, when you know that it's not working and you need to start tracing. You may even start a debugger, okay? But this type of monitoring is unattended. So
Yeah,
it's
because my question was, there could be multiple SQL calls I'm making in one session. So
yeah, and we make sure that we're associating right SQL calls with right data.
yeah.
Okay.
So if I have only one particular SQL session, I was setting as a threshold, but what happened remaining 5 to 6 calls? So
Okay. We are not allowing you to specify it per session. Again, it's unattended. It's always running. Sessions are going up, like they disappear. You setting threshold for your, I don't know, SQL communications. You're setting threshold for your WCF communications. Or you can set up threshold for all resource communications, regardless whether it's SQL, WCF, .NET Remoting, so forth. And then we would be collecting this data. It's not that you turning something on, turning something off. That's a troubleshooting process. I'm talking specifically right now about monitoring process where you set the configuration and we collecting only violations. When you're doing tracing, you can actually yank down all the, dial down all the monitoring, the thresholding, put like, I don't know, zeros. And we'll start collecting everything like a profiler.
Yeah.
I would not recommend because as soon as we start doing that, we determine that we are collecting way too much data and we shut it down. Okay? So.
thank you.
Yeah. Any other questions? Okay. The question is, how is it licensed? Right now, if you have Ops Manager, SMSC, SMSD license, you have this as part of that licensing. Okay. So most likely, if you have, I don't know, EA, you would be licensed for that. And you can install both at the same, either with SCOM integration or without SCOM integration. Yes? Go ahead. Could you speak to the? Yeah, sorry.
We have several web applications that already have some .NET instrumentation in place where we have some exception handlers. Would this tool allow us visibility into exceptions that are happening within our apps, even though we have our own exception handler?
I didn't want to go kind of into deep details, but since you asked about the exceptions and exception handlers, in a managed world, every exception is handled, at least by well-known handler provided by .NET Framework itself. So we effectively using that in order to identify criticality of exception. If, for example, exception happened and got escalated all the way to handle error, which basically shows this kind of screen, server unavailable, try again later, or this yellow screen that I showed, then we treat that exception to be critical. So the answer is, yes, we can work with standard exception handlers, we can work with custom exception handlers, and you pretty much free to configure the way you want. Any other questions? Okay. Slides for this, I believe they're available as part, yeah.
Scalability question.
Sure.
How many agents can report up to a collection server?
Okay. Very good question. It really depends on the amount of data. Our official answer was 300 servers per box. We've seen way more servers. 300 servers per management server. We've seen way more data when you're talking about desktops because they just don't generate as much data, period. Or we've seen about 100 when you're talking about very noisy, very buggy applications, and then we're collecting way more data. But I would say from the capacity standpoint, between 100 to 300, that's a good kind of estimate. And then what you can do, you can have multiple management servers reporting to a single advisor, single OLAP server for reporting purposes. Okay, that's how most customers do that. Okay.
You said this application is available with what?
This SMSE, SMSD license. So if you have Ops Manager, most likely you have this application. Can it be? You need to purchase right now Ops Manager, and quite frankly, this is a good deal. I mean, our AVIcode price was 10 times more than the licensing for per agent licensing for Ops Manager. So, yeah.
So if you have like an online store that you want to monitor end-to-end, say the set transaction, log on, do your bypass, does it understand kind of the transactional flow kind of stuff?
The question is it possible if I have an online store to see end-to-end kind of transactional flow? The thing is, you would be able to see that only for failed transaction. Only when transaction is slow, and it's slow in every step of the way, we would collect all these events from every step of the way, and we will chain it into this kind of transaction. Otherwise, we would show you, let's say, if only the top tier is slow, we would show you only the top tier. Okay? Yep. Okay. The good question about how much overhead we have. Now, the overhead is an interesting question because it really depends. The way we measure overhead is in terms of degradation in requests per second. If without our monitoring tool, you'd be able to process 100 requests per second. With our monitoring tool, you'd be able to process at least 95 requests per second. Okay? So consider that this is a, let's say, 5% performance degradation at most. If you have these kind of calls, if you have SQL that is that slow, let's say 1.7 seconds, our performance overhead won't be noticeable because I'm talking about microseconds. Okay? You won't notice it. Moreover, when exception occurs, the exception handling inside .NET is 300 times slower than the normal execution of the application. So again, our performance overhead is pretty much unnoticeable. With that said, since we are collecting data, we introduce this overhead because we bytecode instrument, let's say, SQL calls before and after. Okay. Bytecode instrument. Yes. The question is whether we change the IL code. We do the bytecode instrumentation, and we have a prefix and postfix R code inside the IL in the runtime. Okay, when we load the assemblies. Any other questions? Yeah, go ahead.
Do you have any virtual labs on TechNet or MSDN specifically using AVIcode with
Yes, I believe that there are virtual labs. I know that there are labs here at TechEd to play during TechEd. And there will be 2 more sessions on AVIcode, how to install and configure. That's more for IT pros. And how to debug application problems, that's mostly for developers. But yeah, they're available.
changes with the next version of SCOM? I think it's supposed to come out next year.
That is correct.
Is that going to play into changes with this product at all?
It will be a lot more tightly integrated. For example, right now, when you're installing AVIcode solution, there is, let's say, our database. There is our configuration experience just to set up that database, right? In OM12, it would be way more tightly integrated. So we're single setup, single infra, and so forth. So from that perspective, it would be way easier to set up and get it going. But from this kind of UI perspective, it still stays the same because we believe that there is a targeted UI, one for operations, and which is inside Ops Manager, and one to developers, which is inside, I don't know, TFS and our kind of UI. Okay? Go ahead. Can a solution monitor applications that are running on non-Microsoft platform? Are you talking about Java? No, Oracle is fine. because Oracle, we support both Microsoft stack for Oracle and Oracle stack for Oracle, as well as like DB2, Sybase, and so forth. We are not currently supporting Java, but that's something that we're considering. Yeah, we have customers who deployed our agents on VDI, like Citrix clients, and successfully monitor gazillions of desktops. And that's a scenario, by the way, where we're not collecting as much data because people are not clicking as fast and failing as fast as the big production boxes. Yes, for us, Citrix client is the same as, let's say, WinForm app. So that WinForm app makes a web service call to someplace else, and we're basically tracing it. From the technology perspective, it's yet .NET process that's making, well, I don't know, invoke calling. So it's the same thing. Any other questions? Absolutely, absolutely the same events. I'm talking about COM+, .NET COM+. So if you're running .NET component inside the COM+, we would capture the same thing. Regular COM, like Win32 COM? Win32 COM we don't support. Any other questions? And again, as far as kind of big implementations, at MMS, we were talking about our implementations at Xbox Live. So there are a number of Microsoft properties that are using it, MS-COM using it. So there are quite a few customers internal to Microsoft, and I cannot say, but there are plenty of external customers as well. Any more questions? OK, thank you very much. Have a good